Mastering Super. In Python's object-oriented programming is crucial for advanced inheritance techniques. It allows dynamic method resolution, enabling flexible and maintainable code. By leveraging Super, developers can efficiently manage complex class hierarchies, ensuring that their applications remain scalable and adaptable to evolving requirements. Understanding Super is crucial for maintainable Python code. It transforms rigid inheritance into flexible design patterns, essential as applications grow. Super addresses challenges in multi-level class hierarchies, allowing developers to write adaptable code. This function is Python's solution for dynamic method resolution, ensuring code scalability and elegance in object-oriented programming. Object-oriented programming, OOP, organizes code into reusable blueprints called classes and concrete instances known as objects, modeling real-world entities. It enhances code reusability, modularity, and abstraction. Core principles include inheritance for hierarchical relationships, encapsulation for data protection, and polymorphism for flexible interfaces. Python's object-oriented programming implementation balances simplicity and advanced features, revolutionizing software development. Inheritance forms the backbone of object-oriented programming by establishing hierarchical relationships. Subclasses inherit attributes and methods from superclasses, promoting code efficiency and reuse. For instance, a square class inherits from rectangle, gaining width and height attributes while ensuring both dimensions are equal. This creates an is-a relationship, where a square is a specialized rectangle. Explicitly naming parent classes and subclasses, like rectangle. Init. Self, width, height, creates tight coupling. This fragile architecture requires manual updates if the hierarchy changes, violating the open-closed principle. In multiple inheritance, managing method resolution order becomes complex, risking conflicts. For instance, if rectangle changes to shape, square's initialization breaks, complicating extensions. The super function revolutionizes Python inheritance by dynamically resolving the next class in the method resolution order. This approach eliminates the need for hard-coded parent class names, fostering flexible and maintainable code. It embodies the principle of writing adaptable code, allowing inheritance hierarchies to evolve seamlessly without disrupting existing implementations. The super function in Python is a built-in tool that returns a proxy object, allowing indirect access to parent class methods without explicitly naming them. It leverages Python's method resolution order for dynamic method resolution, fostering flexible and maintainable inheritance chains. This approach contrasts with traditional methods, reducing brittle coupling and enhancing code adaptability. Invoke super to access parent methods like super, method, args. It's crucial in initMy for initializing parent classes before subclass specifics. Exclude self in method arguments. The proxy handles it. For instance, in class square, super ensures clean inheritance from rectangle, maintaining flexibility and supporting Python's cooperative multiple inheritance.